All right, so here are some practice stoichiometry problems. This is actually how you're going to see it on your worksheets, okay? So here I'm going to give you, one important difference. I'm not going to give you the equation like I did right here. You're just going to get this part, okay? You're not really going to get the equation. You're going to have to derive the equation from the sentence. So, calcium hydroxide and phosphoric acid undergo a neutralization reaction. How many grams of water will be produced from, I don't know why that happened there, from 84.7 grams of calcium hydroxide? So obviously, you'll need to write out the equation, and this is the equation that we have right here. It's already balanced, so I pulled it right off of the question generator on the ChemLinks page, so there's a lot of practice right here. There's not so much practice in the naming of the compounds, but there is a lot of practice of the actual stoichiometry, so I highly recommend that you do that. Okay, so looking at my numbers here, we have, this is horrible. Okay, we got 3, 2, 1, and 6. Okay, now looking at the reaction, the only ones I'm really caring about is water and calcium hydroxide. Okay, so in all intents and purposes, nothing else really matters. Okay, all I care about is those two species. Okay, so let's go ahead and start with what I'm given, like always. Okay, I'm given 84.7 grams of calcium hydroxide. 84.7 grams of calcium hydroxide. Okay, I put that over 1. Okay, I need to use molar mass to get to moles of calcium hydroxide. Okay, so I need grams of calcium hydroxide. If I look at the periodic table, I'll find out that the molar mass of calcium hydroxide is 74.09 grams of calcium hydroxide. Okay, and now I need my moles of calcium hydroxide, right? That's the moles of what I have. I need to get to moles of what I want. In this case, the moles of what I want is water, right? This is where my molar ratio comes in. So let's see, for every 3 moles of calcium hydroxide, I have 6 moles of water, okay? And then I need to go from moles of water to grams of water, because grams of water is what I want. Okay, so 1 mole of H2O is 18.02 grams of H2O. Okay, so now I cancel my units that I have here. Calcium, okay, grams gone. I'm left with just the grams of water, which is what I want. Okay, so I write this out. 84.7 times 1 times 6 times 18.02. So right away I know I'm going to have 3 sig figs in my numerators, okay, because of the 84.7. And then I have 1 times 74.09 times 3 times 1. Okay, down here I'm going to have 4 sig figs with the molar mass. All right, so get my calculator. Do this real quick. We have 84.7 times 1 times 6 times 18.02. That equals, and let's double check that one, 84.7 times 6 times 18.02. Okay, sure enough, that's 9, with 3 sig figs, that's 9160. Okay, and divided by 74.09 times 3 times 1 equals, with 4 sig figs, 222.3. Okay, so 9160 divided by 222.3, with 3 sig figs being in my answer. Okay, 9160 divided by 222.3 equals 3 sig figs for 1.2 grams of water. All right, there is my final answer. So 41.2 grams of water can be produced from 84.7 grams of calcium hydroxide. All right, let's take a look at another one. So ethane burns in oxygen to produce carbon dioxide and water. How many grams of oxygen gas will be produced from 70.3 grams of water? Okay, so again, I will not give you the equation. For this purpose I did, however, put the equation in here. So I'm looking at water and I'm looking at oxygen. So I'm looking at water and I'm looking at oxygen. So my molar ratio here is going to be 3 to 2. Okay, oxygen to water. So start with what I'm given. 70.3 grams of water divided by 1. Okay, I'm going to have 18.02 grams of water. That's the molar mass of water for every 1 mole of water. Right, and then I use the molar ratio of 2 moles of water for every 3 moles of O2. Right, and then I got to get to mass of O2. 1 mole of O2 is 16.00 times 3, which would be 32.00 grams of O2. Okay, looking at that, I'm going to end up with 70.3 times, oops, excuse me. All right, get rid of those guys. Left with grams of O2. So 70.3 times 1 times 3 times 32.00, having 3 sig figs in my final answer. And we have, for the numerator anyways, 1 times 18.02 times 2 times 1, so I'm going to have 4 of my denominator, right? So let's go 70.3 times 1 times 3 times 32.00, with 3 sig figs ends up being 6750, okay, divided by, what, 36.04, right? So that number right there, so 6750 divided by 36.04 equals, with 3 sig figs being in my final answer, 187 grams of oxygen gas. So 187 grams of oxygen gas is needed to produce 70.3 grams of water in a combustion reaction of ethane. All right? So we'll look at one more. Last one, potassium chlorate, which is polyatomic ion that I didn't hold you guys responsible for, but I went ahead and wrote right here. Here's your chlorate ion. Right? So potassium chlorate decomposes into potassium chloride and oxygen gas. How many grams of potassium chlorate will form from 200 or 200? Will form 21.5 grams of oxygen gas. So I want to know how much of this will produce 21.5 grams of oxygen gas. Well, start with what I'm given. 1, we don't need to worry about the potassium chloride because it's not involved in the reaction. My molar ratio here is going to be with 2 potassium chlorates to 3 oxygen gases. So 21.5 grams of oxygen gas, O2, divided over 1. I need to use molar mass right here, right? 32.00 grams of O2, because each one's 16 times 2, right? For every 1 mole of O2. And then I use the molar ratio, 3 moles of O2 to 2 moles of potassium chlorate. Right? And now I need the molar mass of potassium chlorate. Okay, just a little refresher memory, I'll go ahead and work it out, right? Potassium, chlorine, and then I have oxygen, but I have 3 times the oxygen. Okay, so potassium is 39.10, the chlorine is 35.45, and the oxygen is 3 times 16.00. Okay, so obviously this would be, don't need all of the arrows here. Right? All that comes together, 39.10 plus 35.45, okay, plus 3 times 16 equals 122.55 grams per mole. That's 122.55 grams for every 1 mole. So 1 mole of potassium chlorate is 122.55 grams of potassium chlorate. Okay? Moles cancel out. Moles cancel out. Grams cancel out. I'm left with grams of potassium chloride, or chlorate, excuse me. Okay, so 21.5 times 1 times 2 times 122.55, okay, divided by, grams of potassium chloride, divided by 1 times 32.00 times 3 times 1. Okay, so up top I'm going to have 3 sig figs. On bottom I'm going to have 4 sig figs. My final answer is going to have 3 sig figs. Okay, working my problem out, I'm going to get 21.5 times 1 times 2 times 122.55 equals, with 3 sig figs, 5270 divided by 32.00 times 1 times 3 times 1 equals 96. Okay, obviously 96.00, okay, or you can leave it at 96, but understand that I have 4 sig figs here, so I should have 4 sig figs as my denominator. Okay, so I have 5270 divided by 96.00 equals, with 3 sig figs, 54.9 grams of potassium chloride. All right, so these are examples of stoichiometry problems. Okay, of course, like everything else, your understanding of reactions and how to write reactions and balancing equations is vital for your ability to do this, as is your, obviously, as is dimensional analysis. Okay? Now, be forewarned, the next step in the process is going to involve more dimensional analysis other than just one problem. Okay? That's when we start getting to limited reactants and excess reactant problems. Okay? So keep in mind, if we don't have a good understanding of stoichiometry, we're going to mess up the next stuff. All right, so if you have questions, be sure to ask.